together?
Yes, sir.
Alright, now, the first one is what? We said, initially, when we started this class, we said we'll be looking at what? The important points. We said we'll be looking at the important points as far as shear force and bending moment is what concerned. The first one is what? The point and the value of maximum bending moment. So this is the concept. This is how it works. The next one is what? Point of contraflexion. When we say point of contraflexion, the same way you've calculated maximum bending moment, that's the same way you are calculating point of contraflexion. The difference is that you obtain maximum bending moment on your shear force diagram, right? The point of contraflexion, you obtain it on what? Your bending moment diagram. It's the same idea. You know, we said maximum bending moment value has two methods, right? The first one is what? Similar triangle. The second one is what? Sectioning. For this point of contraflexion, it has only one method. Only one method. And the method in this case is what? Sectioning. The method in this case is what? Sectioning. Just because from here, when we bring out these two diagrams, we can relate it to what we know. That's what brought about similar triangle. Are you getting me? Now let's say we want to bring out this. You know, this is, at this point of contraflexion will occur. Do you agree with me? Point of contraflexion will occur just because at this very point, bending moment is changing sign from positive to negative, and bending moment value is 0 at this point, right? Now, from this point, let's say I've sectioned. After sectioning, you know, I'll be having a parabolic shape. I'll be having a parabola, right? I'll be having a parabola. So, is there anything we can relate this parabola in mathematics? Saying we want to do the same way we did for similar triangle? The answer is no, right? Just because we can do similar triangle here, or we can solve the value of x using similar triangle, that's why we have it as our first method. And even we are unable or we cannot solve the value of x using similar triangle, we have used the second method, right? So what I'm trying to say is that generally, or we mostly use the idea of sectioning. You mostly use the what? Idea of sectioning. Whenever you want to do your maximum bending moment, section. And whenever you want to do your point of contraflexion, section. Also section. So depending on your choice, anyone you want to use, you are fine with it. Alright, now, this sectioning, still the same concept, right? Any question? This sectioning, we are still making it of the same concept. Now, from this point, we are sectioning. This sectioning, meaning we are separating this beam, right? You separating this beam, you have this. Any question on that? This is x, this is x, right?
Yeah.
Are we together? Now from here, all I want to know is the location of what? Location of what? Point of contraflexion. Meaning from this distance to this distance, say x meter. Now, how do you get this distance, which is x meter? How do you get this distance, which is x meter? You know, we got the distance of maximum bending moment doing shear force calculation, right? We did shear force calculation just because we identify that distance at shear force diagram, right? Or we identify the distance on shear force diagram. Now, this distance, we are identifying it on bending moment calculation or bending moment diagram. So what does it mean? Am I doing shear force value? Am I doing shear force calculation or your bending moment calculation? Bending moment calculation. Meaning at this point, I'm doing what? Bending moment calculation. So the same way you brought out this beam earlier, that's what you are still doing. Just separate this beam, saying this is part A, this is part B. So from this A to the part of section, what you are left with, bring it out. Then by the time you bring it out, take bending moment or do bending moment at that point. Do what? Bending moment at that point. Then you get the value of x. Now, in some cases, you end up having a quadratic equation. You end up having what? A quadratic equation. Now, by quadratic equation, I will have two roots, right? I will have two roots of the equation, meaning x1, x2, right? Between these two values of x, choose the one that is relatable to your distance. You know, looking at this beam, you've not solved yet. You should be able to predict the distance you get or you'll be getting, right? If from here to here is 6 meters, meaning any distance you'll be getting must not be above 6, but it will be what? Less than 6. Are you getting me? But we don't know the precise distance yet. Is it? And it is obvious that from here, the distance will be greater than 5.
Yes.
And it will be greater than 4. It is obvious. It is what you are saying that what do you say? Between 5 and 6. It is greater than 4, greater than 5, but less than 6. So it's all about you seeing this. It's what you are seeing that you are writing or you are analyzing. So meaning that the distance at the end, it is ranging from 5 to 6. But we don't know, is it 5.1? Is it 5.2? Is it 5.9? We don't know. How do you know? Solve. Now from here, I'm not saying that, let's say we have a quadratic equation. You know, by quadratic equation, this is how you have your equation generally. Ax squared plus bx plus c equals to 0. By that degree of factorization, let's say x1, I didn't know that my value must range between these two guys, right? Let's say x1 is equals to 5.1 meter. x2 is equals to 9.3 meter. Which one are you going to choose, x1 or x2? x1. What if I'm having x2 equals to negative 4.5 meter? Which one are you choosing? x1. Can you see what I'm saying? Meaning at the end, if you have two values, you should be able to know the value you are using, right? Just because by the time you look at this beam, you've seen the value already, but you just want to be precise about this value. That's why you need to solve. That's why you need to solve. Now let's section this beam and bring out what will be left with after section this beam. Let's say you've sectioned this beam. I want you guys to look at that beam. By the time you separate that beam, how many forces are you going to have behind? XX. How many forces are you going to have behind? And these three forces are what? The support, the UDL, and the point load. So meaning, whatever diagram that you are drawing, you must include these three forces. So by doing that, it becomes what? This is my beam. I have this. This is what? So this is my diagram. After sectioning out, I'm left with part A. So by part A, or you say by A, or you say by section A, let's say this is segment A, this is segment A, this is segment B. You are left with segment B. This is it, right? Now from here, the total length of segment B is what? X meter. And that's your interest. That's what you want to know, right? Now, you know, this is A. This is what? C. The next one is what? D. And this is the point with section XX. Now, what I want to do here is that I want to know the distance of AC, CD, and D to the point I've sectioned. Now, for AC, what's the distance? 4 meter. For CD, what's the distance? Alright. The next one, what's the distance? That would be what? That would be what? Relate it to what we did previously. When we said from this shear force diagram, the total length is 4, it becomes 4 minus x. So relate it to that. That would be what? X what? X meter. You are wrong. You guys know the question I'm asking, right? Alright, I said my question is that from here, you guys, you are able to tell me the distance from A to C, the distance from C to D. Now, what's the distance from this D up to the point you've sectioned? X minus what? X minus 5. Is it X minus 5 or 5? X minus 5. Because if from here to here is X meter, and from here to here is 5 meter, then this very portion or this very distance is what? X minus 5. You saying X minus 5. It means that by the time you add this, you still have X, right? So we are saying 4 plus 1 plus X minus 5 is still equals to what? X. This becomes what? 5 minus 5 plus X minus 5 equals to X. This cancels out. X equals to X. So that's what we are saying. Meaning this portion from D up to the point of section, X minus what? 5. And don't forget the tax. The tax is what? Take bending moment about this point if sectioned. Take what? Bending moment about the point if sectioned. You know, the one we did was that take shear force about the point of section. You know, when we said take shear force about the point of section, you know, this is how he denoted it. He said shear force, then X subscript XX, right? Now, I'm taking bending moment about this point. How do you denote it? You have it as what? Bending moment, then subscript what? XX. By doing this, it means that you're already calculating the deflection in your beam. That's why I said for a level, if you are not in the first class, but I believe you should have watched the video. I said for a level, the type of beam you'll be giving is only what? Beam support. You can be giving simply supported beam, cantilever beam, overhanging beam, but the support you'll be seeing is simply supported beam, right? Or you see a pin support, right? The way you expect it. But by this, what this means is that I think we are solving or we are doing deflection of beam. It means the moment you be taking at this point, you are going to equate it to what? Equate it to EI the square Y over the X square. Let's say this is beam. Let's say this is your beam. You know, if this load is subjected to your beam, what will happen? It's going to deflect. It's going to deflect in this manner. Yes. Right? This is the axis of your beam initially. This is the axis of your deflected part, right? The difference between the axis of this beam and the deflected part, it is what we call deflection. Say why. Now, up to this level, how do I get what? Double integrate, right? We call from calculus, say the square y over the x square. By the time you integrate this, what do you have? Dy over the x. By the time you integrate dy over the x, what do you have? You have y. But we are not in deflection class, or we are not in, or for our level, we don't need to. What do you say? Yeah. For our level, we are not meant to. I won't doubt if you'll be doing this semester. I get it. So that's it. So back to what you are doing. Just have it in mind that all what you are doing is the basics. Is the what? It is the basics. It's the simplest of all calculation. It is the simplest of all calculation. All right, now from here, let's take bending moment about this point. Take bending moment about this point. That will be what? Don't forget, whenever you want to solve or you want to, you know what you are doing, you are actually analyzing your beam. We're doing shear force calculation, you are analyzing it. So whenever you want to analyze your beam, look at what you have very well. It's all about what you are seeing. Me saying this, write it down. Me saying this, write it down. That's the beauty part about shear force and bending moment diagram. Now, I want to take bending moment about this point. Whatever load I'm seeing, that's what I'm writing down. It's not about cramming. It is what you are seeing that you are writing. Right? So I'm on this point. I want to take bending moment to this point. By bending moment, first time distance, identify how many forces do you have? You have three. This support, this CDL, and this point load. This, you know, I said it is advisable when you go in a what? Gradual process. Meaning, if you are going in a gradual process, let's say this is your origin. You are going to see this support first. Moving on, you are going to see this CDL, right? The next one is what? Point load. So let's do that. Me moving in a gradual process or in a gradual way. I'm seeing this what? This support. Let's take the moment of this support to this point. By moment, what does it mean? Force times distance. Meaning that for this support, I need the force and I also need the distance. Identify what is the force, what is the distance. The force is what? 27.5. What is the distance? X meter. I'm taking bending moment about this point. Is what you are seeing that you are writing. I'm taking bending moment about this point. I'm not taking bending moment about this point. Are you getting me? It is two different things. Taking bending moment about this point and this point, they are different. So taking bending moment about this point, this guy is going. What's the force? What's the distance? The force is what? 27.5. What's the distance? X. In what direction? Clockwise or anti-clockwise? Clockwise. So what do you have? You then have what? 27.5 multiplied by what? X. This is for this support, right? The next force you'll be seeing is what? UDL, look at it very well. At this level, it becomes technical, but it's still the same idea. So that would be what? First thing first, moment, force times distance. You need the force of your UDL, and you need the distance of your UDL. Now, by force, what's your force? 40. How do you get 40? 10 times 4. Right? First thing first, in what direction? Clockwise or anti-clockwise? Anti-clockwise. Anti-clockwise. If you started this class with us, or when we started this class, we drew a work log saying part 1, part 2, part 3, part 4. This UDL, what part is it going? Is it the 1, is it the 2, is it the 3, is it the 4? Part 3, yes. It is going in this manner. You going like this, you are going against the direction. You are going against the direction of your work log. Say this is your work log, right? Going like this. This is 12, this is 3, this is 9, this is 6. You know, you going like this, the direction, clockwise. You going like this, against it, anti-clockwise, right? Right? You going like this, anti-clockwise, the direction, against the direction. You going like this, what does it mean? In the direction, clockwise. Right? Now from here, apply this concept to this beam. Let's say this is 1, 2, 3, 4. This point load has traveled to this particular point. What portion is it following? Is it 1, is it 2, is it 3, is it 4? It is following 1. We said positive. We have invisible plus here. The next one, you are seeing this UDL. In what direction is this UDL going? Is it 1, 2, 3, or 4? 3. It is going like this. Meaning you are tipping this very edge like this, right? You are tipping it like this. Any question on that? So the best way to understand this, I know it's very confusing, yes, I know. First thing first, what I always do is that if I want to solve shear force and bending diagram, I'm going to, even the last exam I did, this is what I did here. So I drew this particular beam and I assigned this direction, saying this is clockwise, anti-clockwise, anti-clockwise, and clockwise. So with that, I'll be able to, if I'm taking movement, I'll be able to check the direction. Are you getting me? So that's it. Now, this UDL, is it going in a clockwise or anti-clockwise direction? Anti-clockwise. By anti-clockwise, negative. All into bracket, you need the force and you need the distance. Now, what is the force? 40. How do you get 40? 10 times 4. Now, the distance. Let's get the distance. The distance will be what? Don't forget, you are taking moment about what? This point. I'm taking moment about this point. This UDL, what is the distance of this UDL itself? 2. When taking moment, am I going to consider just 2? No. Why? Because I'm going to this point. Going to this point, what distance can I say again? I'm seeing 1 meter and I'm seeing what? X minus 5. I'm seeing 1 meter and I'm seeing what? X minus 5. So it becomes what? This is my force times into bracket 1/2 times 4 plus 1 plus x minus 5. Right? This is the force, this is the distance. Next up, I'm saying this point load, right? In what direction is this point load going? Clockwise or anti-clockwise? Anti-clockwise, meaning 3. By 3, you are saying negative all into bracket. What's the force? 25. What's the distance? What do you have? 25 all into bracket x minus 5. Alright. Any questions so far? No question. Up to this level, equate. Are we together? So what it means is that, mathematically, this is an expression, right? Hope I'm communicating. Mathematically, this is an expression, and this expression, it is representing what? Bending moment about the point xx. Now, once you've gotten bending moment about the point xx, equate it to what? 0. Equate it to 0. Now, you equating it to 0. What do I have? 27.5x, right? Minus 40 all into bracket. This will give me 2, right? Times 2 plus 1 plus x minus 5, right? Negative 25x plus 25 times 5, that's 125, plus 125 equals to what? 0. Any question on this? Moving on, I have 27.5x minus 40 all into bracket 2 plus 1 minus 5, that's what? So you're having minus 2 plus x. Let's write this in a nicer way. Let's say x minus 2. X minus 2, right? So close your bracket. Minus 25x plus 125 equals to what? 0. Now let's simplify this further. What do I have? I have 27.5x minus 40x plus 80 minus 25x plus 125 equals to 0. What are we calculating? X meter. Collect like them. So what do you have? 27.5x minus 40x minus 25x equals to the sum of 80 and 125. What do you have? Okay, so you have negative 205, right? Any question on that? From here, the algebraic sum of all this is what?
Minus 37.5.
Minus. Okay, that's no. This is 0.5, 39.5. That was minus 39.5, right? The algebraic sum of this, what do you have? This minus this will give us 0.2. That's 37.5 minus 37.5. Yeah, that's correct. Minus 37.5x, right? Equals to negative. Equating that to what? Negative 205. This cancels out. Therefore, x is equals to 205. All divided by what? 37.5. What's the answer? X equals to 205. 205 divided by what? 37.5, which is equals to 5.47 meter. Therefore, x is equals to 5.47 meter. Or look at them with the other value. Or what? Okay, I got the value of x to be 5.7 meter, right? I want to write, therefore, the distance, or you say the distance, or you say the location of point of contraflexion occur at a distance 5.47 meter from the left hand support, or
0.53.
all right, or 0.53 meter from what? The right hand support. You consider this B, right?
Yes, sir.
Can you now see that our prediction earlier is correct? I didn't know that the value, or you say the location, must be within what? 5 and 6. After calculation, if I'm getting 4.47, that's totally wrong. Getting 6.47, you are wrong. You are wrong. So that's the concept. Now from here, so these are the important points. Are we together? These are the important points in shear force and bending moment diagram. These are the what? Important points in shear force and bending moment diagram. The same way you solve this, the same way you solve for the location / the value of maximum bending moment and the location of point of contraflexion, it works for any given beam. The steps remain the same. But in this case, we got the value of x easily for point of contraflexion equals to what? 5.47 meter. In some question, you end up having a quadratic equation. I've said that. Instead of we having x equals to 5.47 meter, we got the answer directly. But what if I'm having a quadratic equation? I'm going to have two roots of this equation, say x1 and x2. By x1, let's say we got x1 is equals to is equals to 5.7 meter. And we got S2. And we got S2 is equals to 2.6 meter. Which one are you going to choose between S1 and S2? Are you choosing X1 or are you choosing X2? Why are you choosing X1? Because you looking at your beam is something that you are seeing. Is something that you are seeing. You looking at it, your value for the value for the location of maximum bending moment must range between what 5 and 6. Can you now see the reason why we are telling you that, or why we made emphasis on you drawing your diagram to scale? Are you with me? You draw your diagram to scale. Imagine this diagram is not drawn to scale. How do you see those distance? So that's why it works. Point of contraflexion and maximum bending moment. So that's it. Any question?